All right, so we're continuing the circle notes. This is the second set of circle notes. And we're looking at area, sectors, and things like that. So let's look at number 4. A windshield wiper blade is 18 inches long. So I want you to think about your car. And your windshield wiper blade, basically you can see the circular pattern it usually makes. Here's the blade. The blade is 18 inches long. To the nearest square inch, what is the area covered by the blade as it rotates through an angle of 122 degrees? And again, they're asking for the area. It got a little chopped off, but you can see it on your notes. All right, if you think about this, this is part of a circle. How much of a circle is it? Well, the part of the whole circle that it is 122 degrees out of 360 degrees. So if you think about the words part of a circle, if you ever have trouble remembering formulas, try to logically think your way through them. Part of a circle. This is how I learned it. I'm not good at memorizing formulas. So part, this is the part. Of means multiply, and it's part of the area of a circle. I should have put in there. And the area formula for a circle is pi r squared. Another reason I didn't write the R in, I'm just going to plug in the blade. If the blade is 18 inches long, that's the radius, isn't it? Because isn't it coming out from the center and going to the edge of wherever it hits? So it's going to be pi times 18 squared. Okay, so now, remember, this is great to do in your calculator. The only problem I'm going to see is if you don't have a graphing calculator and you're going to try to figure out this fractionally. Let's see, I could say, 122 can be reduced. Let's do this. Let's do something else easier first. 18 goes into 8. Let's see, this is 18 times 18, isn't it? Let me rewrite this down here. I'm going to write over the stuff down below, and I'll just that's why I kind of chose a bold thing here. 122 over 360. Let's see, let's divide 2 out of both of those. That would be 61 over 180. And then we've got times pi times, come on, pick up here, 18. And I'm going to put 18 times 18 because that's r squared would be 18 times 18. 18 goes into 18. 1 time 18 goes into 18 10 times. By the way, if you have a graphing calculator, you can punch the numbers in, hit math, enter, enter, and it will simplify to the fraction, okay? So I'm doing this for people who might not have a graphing calculator. So what I have now is, let's see, I've got 18 over 10. That can reduce a little further. 2 goes into 10 5 times, and 2 goes into 18 9 times. So I end up with 61 times 9 times pi. Come on, pick up the silly thing. Times pi on top. And then on the bottom I've got 5. And that's not going to simplify. You can see that 5 won't divide into 61 or 9. So my answer would be, in a fractional form, 549 pi over, I wish this would pick up better, 549 pi over 5. Now, if I divide that out, I can get a decimal answer, but remember, most of the time we want to leave our reduce our fractions, okay? So I could say 549 pi. To type that in a graphing calculator or scientific calculator, you don't have to put 549 times pi. If you type in 549 and then hit your shift and your pi button, it knows that you mean to multiply it. And then if you divide it by 5, we're going to get an area of about 344, come on, pick up, 0.9 square inches. So I'm just going to put inches squared. Up here, the units would also be inches squared. This would be my exact answer right here. And this thing that I underlined would be my approximate answer. And honestly, most of the times in real life, for everyday applications, the approximate answer is something we'd probably care more about. If we were comparing, wiper blades or wipers on cars, and I don't know, maybe if you have a problem with a lot of rain in your area like Seattle, you might care how big your wiper blades were. I don't know. All right, here we're just going to put some definitions in. A sector is a region bounded by an arc and its chord. So the sector here would be this shaded area up here, not the center. The center is a little overemphasized in this drawing, but the sector would be this shaded in area up here. So how do I find the area of a sector? Or this segment that's cut off here of this part of the circle. Here's what we do. We take the area of this segment of the triangle over here, or the area that segment basically cuts off on a triangle. That's what it means by area of a segment. It's talking about this part that's cut off over here. What you do, and I'm going to draw on this one up here, and I'll leave the one down below in the box alone. You find the area of the whole sector, which, remember, that's part out of 360 degrees, however many angles out of 360 degrees you have, times the area. So that would give you the whole area of the circle. And then what we're going to do, if you look up here, the whole thing would be the whole area encompassed by that sector I drew. But then I'm going to subtract out this little triangle here. Let me pick a different color so I can kind of color it in. I'm going to subtract out this triangle right here. And that would give me just the piece that's shaded in like this. Okay, so that's what we're going to see in these pictures, or in these type problems. Okay, so let's look at this problem and see how we could work it. Find the area of the segment RST to the nearest hundredths, RST. So this is worded a little strangely, but they're looking for that shaded area that they've got there. So if we remember that shaded area, I'm just going to put area of the segment is equal to, I'm just going to underline that instead of rewriting it to save room on the iPad. That would be the area of the sector minus the area of that white triangle that we see, and it happens to be a right triangle. That's just accidental here. It's not always going to be a right triangle. So I'm going to write it like that. All right, so they put a right angle right here to show me that that's the part of the circle I have. And again, that's just accidental. It could have been anything. It could have been 22 degrees. It could have been 135 degrees. You just don't always think that's going to be 90 degrees. So that's 90 degrees out of 360 in this case. That's part of the whole area of the sector. So that's part of the whole area. If you remember, that's the formula we have been talking about, times pi r squared. Now what's my radius here? It is 4. Okay. So now I need to subtract the area of the triangle. Now I know the area of the triangle is 1/2 base times height. Okay, you should know those formulas by now. If not, you just need to do some studying up on your basic rectangle, triangle, circle formulas, because at this point it's assumed you've been doing this for years. Okay. Now if I want to look at this, how do I know the base? Let's say the base is that 4 here. Height is always a perpendicular thing, so this is an interesting problem because you might think, how am I going to know the height? I only see, maybe I can use that as my base, but height is always perpendicular, and don't we have a right angle here? Since we have a right angle, the height, if you look at it, that's another radius, isn't it? That's another 4. Okay, so let's kind of clean some of simplify some stuff here. If I look up here at the 90 over 60, that 90 goes into 90 one time, 90 goes into 360 4 times. So now I have pi times 4 squared is 16, and I can just write it like that. I can write 16 pi or pi 16 when I'm simplifying. If I were writing it as my answer, I'd want to put the number out front. Over 4, okay, minus 1/2 times 4 is 16. Okay, so let's reduce a little bit more because we still got some simplifying to do. 4 goes into 4 one time, 4 goes into 16 4 times, so this expression is going to become 4 pi. See if I can get it to take on the iPad. Okay, and then minus 1/2 of 16 is 8. So the area of the segment, that little shaded area there, is 4 pi, come on, minus 8. You can see it better over here. It's not showing up well here when I write. 4 pi minus 8 and that's going to be meters squared because it is area, and so it's a square unit. Now, if you wanted to know what this is as a decimal, remember, unless you're told to round, always give an exact answer. So this is where you would stop unless I said round to the nearest tenths or something. So this is the exact answer. It is the preferred answer. It is the correct answer on a quiz or test if I give it to you, unless I say round to the nearest whatever, because remember, we prefer things that are exact. So if I wanted to round it, though, let's say I wanted to round it, I'd say 4 pi minus 8, and I'd get, this is the approximate answer. If I round to the nearest tenth, it'd be about 4.6 meters squared.